live show. Alright, what are we doing here? Let's see. Wait a minute, wait. We want to hook, make sure this is hooked up right. Takes. No, baby. Alright, so the output's hooked up right to the cat bank, and the cat bank's hooked to the battery. Might as well get a tack meter on this. So I'm going to show you two things today. One's a solid state. And the other is the wheel over here. So let's see if it's charging. Oh, that's right. I gotta hook up the resistance and stuff. That's plugged in. Let's see here. That's plugged in. Right now we're trying to hook up a Bedini SSG. It was functioning earlier today, but I don't know what's going on right now. So let's hold on a second. Oh, what the hell? Where is it? You know what? I'm going to hook up a resistor right now. I don't like the way that's running at all. And these pots are too freaking small for me to really work with. It's very uncomfortable working with these. I like the bigger ones, like so, but this one's broken or not functioning properly. The knob is not catching. So, yeah, maybe if they were built, maybe if they sold them pre-built, you know, put together properly, that would help a little bit. Hello. So we're going to put the resistance in, 460 ohms. Here, let's test it out. That might be the transistor. Because I just got done explaining in a previous video how, like, when the transistor amps are flowing through it before you start your device, it's a telltale sign that something's wrong with it.
Twisted transistor.
Yeah, twisted transistor.
$2 super chat from €2. Thanks.
Hello, hello. What's up? Twisted transistor for sure. You can hear it squealing. So we'll get it. I'm working with PMPs now too. I got like 400 of them, so I thought I might as well get into it.
Rank said I'd grab larger 100 watt, 200 watt. Rheostat at 1,000 ohms, 0. Little pricier, around 30, but they hold up better in better condition. Transistors.
Those are potentiometers. Yeah. Yeah, I like the larger ones myself, like this. This is a 25 watt, 1K ohms, but it's only 3/4 turns. And the knob is not turning. I gotta take the knob off and just use the metal part.
Got another €1 from Hamster.
Hey, hamster. Nice. I love the wheel. The hamster wheel is live. We got a new transistor in there. Let's see what happens. 3 volts. Oh, dude, that's not good. Gotta get the pot back in there somehow. Let's see if I can take this knob off of here. Yeah, the knob came off. Sweet. I just hope this thing doesn't shock me. Yeah, now it's moving nice. Okay, sweet. Let's hook it up. I'm gonna hook up the big one.
Which transistors are you using?
I believe it's like it's from Japan. It's a Toshiba. It's got to have the BCE on the pinout. So that's why I'm using this one.
You got some nice feet.
Oh, you mean my bare feet? Thanks, man. I appreciate that. I know it's not the smartest thing to do, but I'm okay with it.
It's for Jerry.
Maybe that's why my transistors are blowing out so fast. It's going straight to ground. Yeah, that sounds stupid, but let me put some shoes on because that might be what's going on. but it ends in like a 200. The one that I'm looking at here. I can't read it though, I'm blind as a bat. I'm not even gonna try. I can read it on the computer, but I'm not at a computer. So like a 2S5 200 or something like that. Something like that. There might be a W in there, I'm not sure. Alright, I need to get my clip, my 2 extensions.
Hamster is taking off. Thank you for the super chats.
Thank you, hamster. See you later. Bye.
Magazine is talking about professional motion machines.
Yeah, we were working on that earlier, but it was a flop. I had the pots, man, they're fallible. It's just another piece to break down, you know? They do wondrous things, but if they're not working right, it's an embarrassment, dude. Totally. So I had the pot all the way opened up, which means I had it all the way turned to the left. And it's all dependent on how you have it hooked up too. So I had mine all the way turned to the left, and it was running really slowly, but it was definitely running.
All Hansen says friction causes heat and loss of energy.
Absolutely. That does not, none of that crap is gonna stop me from busting it out every once in a while and showing everybody that it doesn't work. Okay? That isn't gonna stop happening. That's gonna happen more often, more than likely. But as soon as I get this hooked up, I'm gonna go over here to the solid state real quick and show you how that's running. I want to get the proper chords, so I want these 3 actually. Look at that bowling knot, just right there in my wires. That's awesome.
Boss says if you don't unhook your transistor from the coil, with at least an on-off button when you are done using the motor. The stored whirlwind of energy that the coil holds when it's off slowly cooks the transistor.
Ah, sometimes. Sometimes. That does happen sometimes. It'll come back and it'll be not working. But I've had a transistor work. But you're talking about having a toggle switch, right?
The Rick says it's maybe a Toshiba 2SC5200 decent choice of so it can handle 150 volts peak at an amp.
Yes. That's the one. That's the transistor I'm using. I do have the M that came. I have the MJL 21194G. It's the wrong pinout for the SSG. And all the ones I have appear to be blown out. So they don't function the same way these ones do, and they're supposed to be MPNs. You know, they're just... I'm not... for one, they should fit in this slot and work properly. So So it's gotta be a BCE. It's gotta be BCE, or I gotta make extensions for it. So, yeah, man, it's not BCE, it's CBE, and it doesn't work really. So I don't know. I got 10 of them, and I'm gonna see, because they're supposed to hold or do better, you know, they're supposed to have a higher rating than the ones I'm using right now. But I can't even get them to work, so it's like, It's not like I don't know what I'm doing, it's like they don't work. It's just frustrating, that's all. The whole debacle with the transistors has been frustrating. I mean, whoever made it so that they could just, whatever pinout they wanted to do was okay. Just, it's like, there should have been some sort of standardization a long time ago. That's my opinion. Should have been standardized a long time ago. Transistors should have been something that should have never been decentralized.
Put a 100 ohm resistor on your variable resistor, so it doesn't take the initial spike or spikes apart. The resistor will cause it to fall. Check before the relays off.
So you're supposed to put the 100 ohm resistor first, right? I got that right here, so I can put that in. All I gotta do is swap a couple plugs here.
And right, it says, I've been running the MJ21 194s, 194Gs, since I saw M.P.H video. Yeah, at this point, I've just been hand soldering it together. Sucks when you pop.
I can't even get them to pop, man. It's like a sack of shit. Never mind. But I do, that's why I bought them, because I heard they were dope. You know what I mean? But it's like the whole lot of them isn't working, and they don't fit in the SSG circuit. You gotta make an extension that makes them fit.
It gets even worse once you try to start using vacuum tubes. Connections are all random in fields. Great.
Why would I do that then? Seriously. I mean, I love watching other people do it, but I'm not interested. Really, I'm not interested in all that, man. All I want is to see the thing spin and to see high numbers on the multimeter. That's what I want to see. I love watching the spikes on the shows though, man. Like the plasma spikes that touch the ceiling and stuff. Marv's World, man, his thing is dope. He's got the wood base and everything. Yeah, man, his setup is fly, man. That thing zaps. He's got the nice aluminum, head for the Tesla coil. And that thing shoots like spikes, man, spikes. And just the setup, man, reminds me of something out of the past. Oh, that's 460. We don't want the 461. has gotta be it down here. Yeah, man, it just, I wish that it was a B, C, E pinout for the, and there's a lot of more amps going through that thing than, you know, it has amps going through it when it's basically off, and that isn't good, in my opinion.
Dark Knight is in the house.
What's up? What's up, Dark Knight? So now I'm putting in the 100 ohm resistor. Oh. All right. I think that's in. Let's make sure. Yeah, that's in. All right. Something is not right here. So, all that, we're taking this out, because this isn't working. Was drawing 1 amp at 3 volts. Nah, man, that's ridiculous. And I just put that transistor in there, so that's fucking ridiculous too. I am running it on a 1mm wire though. That might be what's going on here. But I sometimes I have this problem, sometimes I don't. Let's see where this is. Put it in the middle. I think I want to put some electrical tape on that. We'll see in a second. Yeah, that's a transistor. I'm done messing with this SSG right now. I'm done. We're gonna do something else, and if we run this motor, we're gonna run it without the SSG. It's like 3 transistors in a row, man. Something's obviously disconnected or cross-wired or some crap. We shouldn't be doing this right now because everything's in a disarray. Alright, so
They just be resonance. Amps aren't high enough for transistor to burn out. Try giving them a good spin while on.
yeah, Mike says that the transistor, if it makes that hiss when the magnet's going by, if it's just going real slow and it makes that hissing noise, that is probably only working half good, and it'll still spin, but it's a busted transistor. It's really not supposed to draw amperage until you get your first spin in there. Alright, let's see. I'm just making sure nothing's touching. Hear that? So it'll still spin. It'll still spin pretty good, but you know, there's an extra hiss there that's not supposed to be there.
Yanni is in the house.
What's up, Yanni? Here, let's try messing with the pot. I like it. All right, we'll give it. We'll say it's okay. We'll say it's resonance. I don't mind using a half working transistor. Personally, as long as it makes it spin, I'm happy.
All right, I got a question. We only got 4 options. But how many magnets would you use in a pulse motor? 2, 3, 6, or 9? 22 volts, 32% say 2, 32% say 9.
So 2 and 9 are leaders, and that's what I use a lot too. 2 and 9.
And then Yanni comes in and says 2, 4, 8.
Yeah, I know. I know. I don't have any. I have 4. I have 2. I have 4. I don't have any 8 though.
Right. Do you have an LCR meter to test your pots?
No. No. And man, these pots are tiny. You see these hands? No, man. This is like not the way I want to go with this. See, the knob has got to be like at least that big, and it's got to work. It's got to work. When I turn it, it's got to go. You know. I need a brand name that does it like that. See, this pot is awesome.
Yanni asks, is that based on dwell and pulses as the magnet passes?
If you're talking about the transistor being blown and when it making the hissing noise when it passes, yeah, it's doing that. I don't know if it's blown though. I mean, I don't use pots that often. I'm going to start trying to use them, but they're frustrating to work with. So, I mean, the results barely outweigh how frustrating it is for me. And just right now, because I don't have the right connectors to put everything together, so I'm using makeshift connections. And you know that's why my stuff looks like crap, is because I'm using I'm using connectors like this. That's why. 100%. But, for those of you that look through all that and see what's really going on, I appreciate that. So this is a 2-magnet rotor. It's actually a 4-magnet rotor with 2 magnets in it. So that's awesome. Let's take a look at the solid state real quick. We currently have 433 hertz being pumped into the Litz wire coil on the bottom here. So this coil on the bottom, this teeny coil, it's got about 50 turns, in between 25 and 50 turns. I'm not sure exactly how many turns is there, but it fits in that little bobbin. About 20, in between 25 and 35 turns, I want to say. It's really small. Of a Litz wire, which is 100 strands of 38 gauge, twisted up to be an 18 gauge wire. Alright, and so the multimeter is hooked up to the battery. We're going to charge the battery. Wow, it's going up so fast. But I think any kind of pulsing going into the battery is going to revitalize it in some way, shape, or form.
Boss said it would be safer to wire those, or solder those pots to the wire. I said, use them to.
Yeah, I can't solder shit. Sorry. Seriously, man, I have no soldering skills whatsoever, and I have a violent tremor. I even have a soldering gun over there. I bought one. I was going to attempt to start the solder. I went through like 3 rolls of solder, and I didn't get anything done. So, no. Somebody else would have to do that for me.
You just, he looked at me.
But I'm sure you're right. I'm not saying you're wrong. I'm sure you're right with that. Because I'm sure there was definitely some contact going on that didn't need to be happening, and that's exactly why it didn't work. But I wouldn't even mind getting the baby spades to just hook it up properly. You know, get the baby spade connectors and hook it up the correct way. Would even be better, in my opinion, you know? Like they do it on the K-Energy.store channel, and like Yanni, like they do it on your channel. You know, get the proper connections.
Can you summarize what I'm looking at in 3 words?
Pulse motor mayhem.
Woo!
So there's a double pull, double throw relay with the spade connections. So I mean, I've been dabbling in the proper connections a little bit. And this is just 3 volts in right here. I like that though. It's moving pretty good at 3 volts. So I've now cut the power off of this. We're gonna see if any of it sticks. Like because it is like the battery won't charge. So we're trying to revitalize it right now. And if it goes down to 971, it's not working. It's going all the way back down to where it started at. It's at 9775 right now, so no, I don't think it's charging the battery, but that's the battery's fault. It's not because we're not generating it, energy. But here, let me do this. We're gonna take the cap bank off. We're gonna take the multimeter, and we're gonna do an oscilloscope reading on the coil on top of the lid splitter coil. So the pickup coil, I'm now hooking the multimeter. So at half a volt in, we're getting 56 volts of AC out. 100 milliamps at half a volt. So at like 5.5 volts, 1 amp in, we're generating 341 AC volts. That's amazing. So this SSG right here, this setup, is charging this battery. Let me turn it up high enough. It's got to be up around 5 volts to even get a decent output though.
Rick says, I like testing out smaller lead acid batteries just for that reason. They won't stay for smaller battery. Pete is back.
Hey, hey. So I don't know, man. I think there's something wrong with this circuit, honestly. It has had a lot of trauma. Woo! There's your 18 gauge strand for you. 7 volts. Jesus. Woo! Turn that off real quick. The pot was stuck. It's either stuck or it's all the way over. Oh, it's all the way over. That's what the problem was. And that's why it was going so fast. Alright, let's do that. But my light was on. My SSG light was blinking. So
County Lakes Falls Motor Mayhem.
awesome. Haha.
That's cool. This is also known as Bandini SSG pulse motor testing and learning. Waves bouncing at the end of the wire and then coming back like water.
Heck yeah. Just like Bruce Lee. Like water. You must be like water. Sir. just trying to eke this up to 12 volts. And it is not, see what I'm worried about though is that it's not, the output isn't charging this battery. Might be the coil, could totally be the coil.
Made a shout out video to your channel showing Oscilloscope ramp.
Nice. Yeah, man, I saw that, a few of the things on your channel, man. That's really clean. I appreciate that.
Love from India. Love
India.
And love for India.
Love for India. Word. Word. So we'll leave it at 3 volts. We'll see if we can get this thing spinning really, really fast at 3 volts. So at 9 volt, 10 volts, we're generating 434, 35 AC volts. That's amazing. Heck yeah, I like that. 9 magnets. Okay, you wanted to see a 9 magnet rotor in action? Boom, boom, boom. Alright. So we actually have to prop this one up, which is okay. Like butter?
Watch it.
Put
Is
some
this a
salt in that water.
Is this a solid state setup?
Up here, yeah.
Bifilar?
It's actually a 4-filer and a Litz coil. The Litz is 138.
Alright, if connecting into the SSG circuit and normal 2 battery in and out, does it then start up oscillating? No rotor, just residue.
I don't know what that means. Let me read it real quick. We're connecting it to the SSG. No, the solid state is not connected to the SSG. Welcome, welcome. Man, I have to find a wrench. I don't have a wrench. This sucks. Where's my wrench?
This one spins and stores.
I'm looking for my wrench.
Alright, I'll put it spins.
It is capable of generating electricity, so it can store if I want it to.
You got this.
You gotta understand, I'm the maestro. I can hook this up any way I want to. So if you have a suggestion on how to do so, I'm more than willing to listen. As long as I've got the pieces, I will even hook it up for you. But right now, this one is not hooked up to the battery. It is hooked up only, the multimeter is hooked up to this coil alone. And that's a 4-filer. It's got 13,000 turns of 32 gauge in it. And ferrite core. So it's generating buco electricity, man. It's awesome. That's only 10 volts in, 1.2 amps. We're getting, you know, a lot. We're getting a lot. Like 450 volts. Now, how many amps? I don't think we're getting many amps. Maybe a little bit more than, say, this pulse motor will generate, though.
Would you call this whole thing a battery?
No,
The solid state part?
no. No, it's more of an amplifier than a battery.
Yep. Gauge.
And I don't know, it's all, but it's like AC/DC electricity, you know? Could be a battery, I guess. It's not what I set it up to be, though. But here we go. 9-magnet rotor. And they're big magnets, too. Now, it's not going to be as smooth a ride as the other one because it's not magleved right now. I could maglev it though. Should I maglev it? Yeah, let's do that. Just getting this stuff off of here. I want to clean my workstation a little bit. So it's got a frequency generator hooked to it, the solid state. And we're pumping 433 hertz into the system here. And 9 volts, we're getting 420 out. We're getting 420 AC volts out of this thing, man. That's awesome. That might be what's going on. Here, let's see how this thing runs. That's running smooth. Now, if I may ask as to why a 9-magnet rotor, I think I already know the reason, but I just want to know. And I'm not going to tell you what I think the reason is first. I love a 9-magnet rotor. I love running 180-degree coils on a 9-magnet rotor. So you got your on, your off. Okay, so I think the way it's set up is definitely not going to let it run. There's too much friction and too much weight. So what I have proposed is to maglev it. Nice, I got it on the first try. Sweet. All right, let me get some glue. All right.
Now he chooses it for the sine wave pulses. The
The-
magnets.
Okay, so it's like the triple sine wave. The triple 120s. I get it. Ah.
Yeah, you can read that one.
Houdini's single coil SSG is more so a switch noise harvester. Multi-coiler was harvesting noise. Connecting as a... Okay. I have no idea what you're talking about, but I appreciate it. And I don't mean any disrespect to the people that came before me. That's not what I'm trying to do here. Disrespect anybody. I'm not trying to disrespect anybody. I just don't get the way you explain it. I don't understand. Like, when they said Bedini for the first time, I'm like, who's that? That's literally what I said the first time I heard his name is, who is that? And that's important. That was a very important question for me. There we go. Just got to get my centering disc off of there and then should be good. There's my 4007s. Now these things will really poke right into your foot if you step on one because they're so tiny. Oh yeah, but I mean, I'm the only person that does this in their bare feet, so. Perfect. Beautiful. There is one magnet in there that is loose though. So off of this coil right here, where are you getting your sine wave from? We'll hook it up, we'll see what it looks like. Is it gonna be the trifilar? Come on, we'll look at it right now. Where do I hook that up at so we can see this, the sine wave of the 9 magnet rotor? Is it the output? You gotta put it on the output, right?
Basics like 3 things. Why choose the number? Sine wave pulses.
No, yeah, where am I hooking up so we can see those pulses, man? I want to see them. I've always liked 9 magnet rotor, so I want to see that. So look, we'll do our oscilloscope. We're gonna hook up to the output of the SSG. Hold on, let me just-
Right before the diode and on the negative can go across the core.
You want me to go across the coil to get it? Yeah, I don't know about all that. I'm gonna hook it up to the trifilar strand though, and we'll get the AC reading. Or should I, no, you want me to hook it up to the drive coil, yes? Oh man, this is getting really, really not cool. Alright. We're not there yet.
Mainstream, they all read the same way, just different voltages. Not so much generators, it needs to drive power like wind or an engine. This is transferring energy to a electricity source, so electric couplers,
So I'm gonna hook it up to the trifilar, which is only gonna be reading AC, not anything else. because this is becoming a mess, and I'm just not gonna keep moving stuff around anymore. Alright, gotta untangle it though, real quick. Alright, here we go. Connecting to the trifilar now.
So more is not always more in this context.
Right. It's not more speed for sure. 9, I always like 9. 9 works well. It works well on a bigger wheel, I think, than a smaller one. I love 9. But in this regard, I think that the sine wave is going to be mainly. Hey, all right.
Wasn't automatic. That's good.
See if we can recoup. Man. Yeah. I like 3, I like 6, and I like 9. I like 12 too.
They're coming back.
All right. Heck yeah, check this baby out, man. It is moving. 5 volts in. Almost an amp drawn at 5 volts though. 5.5 volts, that's crazy. It's a lot of amps.
We got some celebratory reaction.
Woohoo! How fast that thing is going. That is unbelievably fast. I'm gonna cut back the power on that. Whew. Amazing.
Wow.
We almost had 3 volt. We still got 3 volts coming off the trifilar. That's amazing. It's a 20 gauge strand. All right. So, I was just thinking that there's really only a few readings that actually matter. Tremendous amount. One is how much power is being drawn from the power supply. Not how much is the power supply feeding it, but how much is it actually using from the power supply. So that reading is important. The output reading is important.
That's nice from that coil to wheel size. I want it to go thin, probably see this out.
All right. And that's awesome, because that's coming off a 20 gauge strand. It's pretty small, 2.5 volts. Actually, I wanna look here. I wanna see. The output reading. I just had to flip that a bit so I can get another clip to. Alright, here we go. Huh. There we go. Alright, that's an interesting reading to me. That's crazy, like a sawtooth. Like a little staircase that's lopsided. Look at that. That's pretty neat. And we get a spike every once in a while. So I would say that it's not a clean wave though. Looks like we're generating 60 DC volts off the end there though. That's pretty, that's a little. Is that right? That's gotta be right.
Are they machines that relay on magnets?
Yeah, they react on magnetism. The base of the transistor closes when the magnet passes by, causing motion. The end result in one of these is motion. Okay, there's a lot more in between there, but I'm not going to get really into it. We need a textbook maybe to get all into that part of it, but I understand it for the most part. The magnetism closes the transistor, and the transistor, or it'll close the switch. You know, if you have just a switch like this, it'll close this. So then put it next to the. Hear that? That's the switch closing. Okay? And that's pretty much all that's going on. But that's a lot of energy coming out of the back end of this is the output of the SSG. It's about 60 volts. I mean, I am running a power supply through it. That might be why it's doing that. That's quite a bit of energy. I think some of it's frothy though. It's got to be frothy. There's no way that this battery would be charged like instantaneously if I hooked it up. I don't know exactly how that transforms into usable energy right there, but that's a pretty good reading for 3 volts in. That's 6 volts in. It's crazy, man. That's a lot of voltage right there. That's DC voltage too. Wow. Because we're really not generating any usable energy. This is what I'm trying to say. Like, right now at 3.3, like 3 volts, you're not going to charge this battery at 3 volts. It's not going to work. But still, even though it's not going to charge the battery at 3 volts, you're getting 66 DC volts off the end of it. Amazing. All right, let me recover my disc. We have the phone plugged in now. Wow, that's hardcore torque right there. Flywheel applications. All right, I'm gonna get something to drink. I'll be right back. Oh, you know? Yeah, no. There's something wrong with the output because this battery isn't charging. Or no, that's what I said. It's not going to charge this low.
How are the magnets positioned in the rotor?
40 degrees of separation. It's 9 magnets.
I am Brazilian. Could you send me how do I make a generator like this?
All right. You need a transistor, preferably B, C, E, and a pinout. Woo-wee. All right, and when you have the transistor, you want to get something to clip them to clip things to. You want a bifilar coil. Okay, you want a trigger strand of about in between 26 and 32 gauge. You want a drive strand of anywhere between 18 and 24 gauge. Okay? You want to wrap those two together at the same time for about 750 turns. You want a bobbin that's shaped more like this, real crunched in like that. That's what you want. You want that magnet to saturate the coil as quickly as possible. Alright, so you want to hook your base to one end, to the beginning end of your trigger coil. And then you want to hook the other end of your trigger coil to your emitter. Okay, so you want to go base to trigger, trigger to emitter, and then you want to go drive to emitter, and then the other end of the drive goes to your power supply. And then the power goes in to the collector. So B, C, E, base, collector, emitter. Power goes into the middle. The end connects to the coil or your drive, the emitter, and the base connects to the trigger. And then all of your grounding goes to your emitter, because your emitter is going to connect ultimately to the negative end of your power supply. And that's how you build it. And it should work, just like that. Nothing fancy. Now, for resistance purposes, you want a light. You do want a light, like, let me see what light you want. This is it. And something like this, in between your collector and your emitter. So you want to put this, clip it to one end to your collector and the other end to your emitter. And that's it. That's pretty much.
Nice recovery.
All right. So we're going to go in, all in. Now with this coil, if I turn that up to 12, it would break it. It would break the table. Seriously, it would be flopping around so hard it would break the table. So I'm not going to do that. I'm going to stay right here at 3 volts. This is where I like to be. It's nice, it's safe. Now the magnet size here, these are really big neos in here. This is 40 millimeters by 20 millimeters round neos. They are big, they are powerful. You have no trouble starting this motor. There is, it's not like you need them that big, but the bigger they are, the easier everything's going to work. Okay, like if I were to double them up, it would be that much easier than it is now, and it would saturate this coil that much faster. And you know, people just the strength of the permanent magnet side of this whole thing is underrated, I think. Because yeah, you can make it spin with little tiny magnets, and you can get electricity out the other end with little tiny magnets, but you know, you can probably get more, or do different things. Because I know a little tiny magnet is not going to get this going. Like the face of the magnets that I'm talking about are 40 millimeters, so they fit like on this thing pretty well. You want to match up the geometry of your coil and the geometry of your permanent magnets to be about the same size. You know what I'm saying? Like the face of your magnet and the face of your coil, the poles of your magnet and coil should be about the same size. Or it should fit in the hole in the center. Or, you know, there should be some definite, like this belongs to this motor kind of thing going on there. There should be something like that happening. I think it's really, really, really cool. This rotor's been around forever. We got so many videos with this rotor. It's got 3 different paint jobs since I built it. And it's just fantastic. So, I don't know. Looks like we're kind of ready to call it a day. That's great. 61.75 volts coming off of my SSG.
There's got some heartburn.
But it's not enough still yet to charge the battery at all. You know, if I turn it up high enough to charge the battery, it's going to go all over the place. So this ultimately is a bad design because you can't turn it up high enough to charge it because it's already going so fast. And ultimately, it's the shaft that's the problem. It's so small. It's a tiny shaft. It's only a 1/4 inch in diameter. And that's ultimately where the problem is. And then the only reason that I'm using a quarter inch shaft is because the pegboard has 1/4 inch holes in it. And I don't have any like tools, typical tools that, you know, somebody that would be building stuff would have. I have a drill. You know, typically in your household, everybody has their drill, their Black & Decker. That's what I got. You know, if I try and screw like a huge bolt into a 2x4 with this thing, it's going to get stuck halfway and it's not going to go any farther. There's no way I could charge the battery up full blast. It's just, you know, I don't have industrial equipment. I don't have professional equipment. I have household equipment. And this is the best I could do with the household equipment that I had when I was actually doing it. Now this is the after effect of me doing it. I'm making videos and sharing it with people. But this is awesome. And I'm glad that I think it was Boss, told me to spin it, give it a spin anyway, and look at it go. I think it actually corrected the mistake that was going on with the transistor, because it starts off at 0 now. So that's awesome. Because, I mean, if you're pulling amps before you start spinning your motor, you have a problem. It's not supposed to do that, but you should definitely spin it anyway, see if you can correct that problem. But, yeah, I'm going to call it for today. Thank you all for coming back, for checking it out. Really appreciate this rotor right here is awesome. I appreciate everybody in their opinion. The 9-magnet rotor is king in my mind. Although you do get a little bit more speed and maybe even a little bit more generation off of a 2-magnet rotor, the 9-magnet rotor in my mind is king, like I said. It's my favorite. This 9-magnet rotor came before any of these other rotors. And that's gonna be that. Thank you so much. Peace out. Have a wonderful day. Please subscribe. Bye now.